Okay, 5-8 radical equations and inequalities. So a radical equation is an equation that has a variable in the radicand. So if there's a variable under the radical. To solve radical equations, raise each side of the equation to the same power as the index. This will eliminate the radical. You must check your answer. Because you may end up with an extraneous solution. So that's a big fancy word that means we've done everything right, but it doesn't actually work. All right, so how do we do that? Well, first of all, we get the radical all by itself. Determine the index and raise both sides of the equation to that power. Finally, we're going to solve the equation. And lastly, we have to check our answer. Okay, so let's look at number 1 there. It says solve the square root of y minus 2 minus 1 equals 5. If you notice that minus 1 is outside of the radical. So the first step said to get the radical all by itself. Is he all by himself? No. So I'm going to add 1 to the other side so the radical can be all by himself. So I have the square root of y minus 2 is equal to 6. Okay, so the first step said get the radical by itself. The second step says determine the index. What's my index? If there isn't one, we assume him to be a 2, right? So now I'm going to raise both sides of my equal sign to the second power. I can't do it to 1, I have to do it to both. So raising the square root to the second power undoes that guy, right? So I'm left with y minus 2 equals 6 squared, or 36. All right, so we got the radical by itself. We determined the index was 2, and we raised both sides of the equation to that power. Number 3 says solve. So now we can solve for y. This guy turned out a whole lot easier, right? We got rid of radicals, and now he's just an Algebra 1 problem. So I'm going to add 2. So y equals 38. Number 4 says you have to check your answer. Now, do you necessarily have to show me your work for checking it? No. Let's plug in 38. 38 minus 2. 36. Square root of 36 is 6. 6 minus 1 is indeed 5. That guy works. Like I said, you don't have to show me your work for checking it. Okay, but you have to check it. Okay, questions so far? Let's skip down to number 3. because he's a little bit easier. So number 3 says, parentheses 3y plus 1 all raised to the 1/3 power plus 5 equals 0. This guy says radical equations and inequalities. But this guy has fraction exponents. Well, that's okay. We can write them in radical form if you want, but what do we know about the index? The index is just a denominator. Okay, so this guy right here would be the radical part. So let's move the 5 to the other side. So I have 3y plus 1 all to the 1/3 power equals a negative 5. Okay, so we just decided the denominator was the index. I'm going to raise both sides of my equation then to the 3rd power. Also think about, what do I need to multiply 1/3 by so he becomes a whole number 1? 1/3 times 3 is 1. Alright, so those guys undo each other, and I'm left with 3y plus 1 equals negative 5 to the 3rd power. You have your chart or your calculator? 125, and he's negative, so he'd be negative 125. Alright, we got the radical by itself. We raised the equation to our index, which was 3, and now our step number 3 was to solve it. So we're going to subtract 1. So 3y equals negative 126. So divide by 3. Negative 42. Okay, now we have to check that guy. Three times a negative 42 plus 1 gives me negative 125. The cube root of negative 125 is negative 5. Thanks, honey.
Yeah.
And then negative 5 plus 5 does indeed equal 0. So that guy is good. You can type it into your calculator too if you're not sure. We could do the, oops. Negative 5 plus 5 is indeed 0. Okay, questions on either one of those two? Okay, now let's go back and look at number 2. Number 2 says the square root of x minus 12 is equal to 2 minus the square root of x. Remember, we can only combine radicands, or radicals, if they have the same radicand and the same index. Well, the radicand for this guy is x minus 12, and the radicand for this guy is just x. So even if I added this guy over here, nothing would really change with that. Okay? So we already have one radical by himself. Let's just go ahead and see if we can get rid of this guy here. Okay, so what's my index? 2. So I'm going to square both sides. Okay, so when I square the left-hand side, if I square the square root, it goes away, and I'm left with x minus 12. But what happens over here? How many terms are inside that parenthesis? 2, right? So that guy I'm actually going to have to FOIL. Okay, so here we go. First ones. Four. 2 times the negative square root of x is negative 2 root x. Negative x root x times 2 is another negative 2 root x. And negative x times a negative x gives me a positive square root of x squared. So the square root of x squared makes this guy just become x. All right, so I have x minus 12 equals 4 minus, I'm going to combine my terms, 4 square roots of x plus x. Well, he doesn't look all that better at the moment, right? But we still have a radical. So let's see if we can get that radical by himself. So let's get this guy all by himself. If I do that, I'm going to subtract x. Okay, that helps a little bit, because that means these x's are going to cancel as well. And then I'm going to subtract a 4. Okay, so negative 12 minus 4 more is negative 16 equals negative 4 square root of x. Okay, that looks a little better. Is the radical by himself yet? No, not yet, right? We have to divide by negative 4. Okay. So I get 4 is equal to the square root of x. Oh, hey, that looks a little better, right? How do I undo that radical? Square them. So I got 16 is equal to x. Okay, what's the last step? Check it. Okay, I have to check it. So the square root of 16 minus 12, is that equal to 2 minus the square root of 16? Whoop, sorry. All right, well, 16 minus 12 is 4. The square root of 4 is 2. Okay. 6 square root of 16 is 4, so I got 2 minus 4. So I get a negative 2. Did it work? No. We went through all of that work. We did everything correct. And we got an answer, but it didn't work. So then we have to write no solution. We got an extraneous solution. And that happens sometimes, right? We did everything right. We were going good. Everything looked great. Now, every time you end up with a radical on both sides of the equal sign, is it going to be a no solution? No. Okay? This time it just worked out. What I want you to see, though, is that we can do everything correct, and it still doesn't work out. Okay, questions on any of those? Okay, grab your worksheet. I want to... Yeah, go ahead.
Wouldn't it work because negative 10 times negative 10 doesn't work?
So be careful when I go to check it. So you're plugging it back in here. When I take the square root of this guy, I'm going to get 4. So 2 minus 4 gives me a negative 2, though. And when I do it here, I get a positive 2. So when I get down and I've simplified it by plugging it back in, it doesn't actually give you the same thing on both sides of the equal sign. Does that help, China? Okay. Okay, let's look at your worksheets. I want to look at a couple on your worksheet, and then we'll talk about inequalities because they're a little bit different. Not a whole lot, but just a little bit. All the way up through 18, or up to 18. One through 17 are all equals. How about pick a column to do? What do you think? I could bet money on you're going to do the right-hand column because there's one less, right? Okay. Do you guys want to pick one of those to me to do? Pick one, any one, 1 through 17. Colden, you want to pick for us? Which one should I do?
12.
12, you got it. So on number 12, I have 2d plus 3, all raised to the 1/3 power, equals 2. Okay, what's my index? What's my denominator? 3, right? So raise both sides to the 3rd power. So I get 2d plus 3 equals 2 to the 3rd is, use your chart or your calculator, 8. Alright, now I'm going to solve it. 2d is equal to 5. So d is 5/2. I'd take 2.5 as well. Okay, let's plug it in. 2 times 5/2. That would be 5. 5 plus 3 is 8. Cube root of 8 is indeed 2. So that guy works. Okay, still get the radical by itself. Get rid of the radical. Solve it. Check it. Sound good? Questions on equations, like I said before we go to inequalities. So I want you to just pick one column, either the left-hand column or the right-hand column. It doesn't matter to me.
And we're not doing 18 through 24.
Yes, we're going to do them here in just a minute. So yes, Abigail, you can either pick the evens or the odds on the top part. Okay? Okay, let's go back to your notes and let's talk about inequalities. So a radical inequality is an inequality that has variables in the radicand. Solving these is similar to solving an equation. Okay, so if I were going to solve this guy as if he were an equation, I still need to get the radical by himself. Is the radical by himself at the moment? No, he's not. So I'm going to subtract the 4. So that Square root of 3x plus 6 is less than or equal to 3. Yeah. Oh, sorry, yes. Thanks, Riley. That would have made a big difference here momentarily. Thanks, honey. So it's 3x minus 6. Okay, now what's my index? It's 2, so I'm going to square both sides. So I have 3x minus 6 is less than or equal to 9. Add 6. So 3x is less than or equal to 15. And then we'll divide by 3, so x is less than or equal to 5. Okay, let's think about that for a second. What are some numbers that are smaller than 5? 4, right? 0. What about like negative 100? Is that smaller than 5? Yeah, but let's think about what happens. What if I plug negative 100 into this guy? Well, that would be negative 306. Can I take the square root of negative 306? Not yet. Tomorrow we'll be able to, but not today. So I can't take the square root of negative 306. In fact, I can't even take the square root of anything that's negative. Can I take the square root of 0, though? What's the square root of 0? 0, right? Go through that. You had it right the first time. Was it one of those trick questions, right? Okay, so I could take the square root of 0. 0 times 0 gives me 0, right? Okay, so I could take the square root of 0. So I'm good for numbers that are smaller than 5 as long as I don't go too small and make this guy negative. I can't let my radicand go negative. So when I have a less than, and only when I have a less than, I'm going to take my radicand and make him greater than or equal to 0. Because he could go to 0. We can take the square root of 0, but I don't want him to go negative. So I'm bounding my radicand from, I'm stopping him from going too far. Okay? So there's my formula, essentially. So I'm going to say 3x minus 6 is greater than or equal to 0. And I'm now going to solve that. So I'll add 6. And then I'll divide by 3. So x is greater than or equal to 2. That's saying that anything that I put in that's smaller than 2, if I were to put 0 in here, 3 times 0 is 0 minus 6, that guy would be negative, right? So it's saying I can have numbers that are less than 5, but don't go too far, because once you get to 2, after that, they would be negative. Okay? So you can leave your answer right like this. Essentially, this guy is an and. Or you could write him as the and. Do I care? No. Okay. Questions on that before we do number 5? Okay, so subtract 1. Number 5 says 1 plus the square root of 7x minus 3 is greater than 3. So I'm going to subtract 1. So I have 7x, square root of 7x minus 3 is greater than 2. Again, my index is still 2. So if I want to undo it, I'm going to square both sides. So 7x minus 3 is greater than 4. Let's add 3. So 7x is greater than 7. And divide by 7, so x is greater than 1. Okay, let's talk about things that are greater than 1. Okay, 2, 12, 100, right? When I start putting guys into my radical, does he ever go negative? What if I put a 1 in there? 7, or I guess I can't put 1, it has to be greater. So 2, so it would be 14 minus 3, that would be 11. The square root of 11 is positive, right? So no matter what I put in there that's bigger than 1, he will be always bigger than 1. So this guy I don't have to bound because he'll never go negative. You only have to bound it if the inequality is a less than. Okay, so let's go look at your worksheet. I want you to do all of the inequality ones. So you're going to do all of 18 through 24. But let's figure out which ones we have to bound. Is 18 a less than? Yes, so we have to bound to that one. I'm going to circle it. How about 19? Is 19 a less than? Yep, got to bound it. How about 20? Ooh, that's a greater than, but what's crazy about that guy? There's a negative out front, right? So I'm going to give him a 1. And what happens when I multiply or divide by a negative? Flip the inequality, right? So this guy, after I divide by a negative 1, becomes the square root of 2a plus 4. He's now less than or equal to positive 6. Do I have to bound that guy? Yes. $21, do I have to bound him? No. How about 22? Yes, this guy will have to bound because there's a negative out front, so it'll flip that inequality. 23, do I have to bound him? I'll add the 3, so I'll get 6, and he's a greater than, so no. And how about 24? Yes, because I'm going to divide by a negative 3, so the inequality will flip. So you have to bound 18, 19, 20, 22, and 24.
1 through 17, you said we can pick a column.
Yeah, pick odds or evens. Pick a column. I'm good with that. Okay. Questions from anybody on anything so far? Okay. I'm going to stop my recording.